In this lesson, you will learn about transformation of triangles. In Math 1, you performed rigid transformations that do not change the size or shape of the pre-image. A rigid transformation of a pre-image produces a congruent image. Rigid transformations include reflections, rotations, and translations. In Lesson 3 of this unit, you learned about dilations. A dilation is a non-rigid transformation and will produce a similar image. So some review of the rigid transformations you have previously worked with. We have reflections, rotations, and translations. So we are going to perform a sequence of transformations and then determine if the resulting image is a congruent figure or a similar figure. So example 1, we have triangle XYZ will dilate by a scale factor of 1/2, then be rotated 180 degrees. So let's first start with writing our coordinate notation. So we have our XY that will then change to a scale factor of 1/2, so it will go by 1/2 times our X and a 1/2 times our Y, using that dilation scale factor. And then once we do a dilation of 1/2, it says to rotate 180 degrees. So look at our chart for rotations. Rotating 180 degrees says we'll take our ordered pair and make the X negative and the Y negative, or you could think about making them opposite of what they originally started. So rotation is -X, -Y. So let's first start by listing our points. In this triangle, they're called X, Y, and Z. So point X, it is at -4, +2. Point Y is at 6, 0. And point Z is at -2, -4. So following our coordinate notation, we will do half of the X times, or 1/2 times our X, 1/2 times our Y to determine the ordered pairs for the dilation. So 1/2 times -4 is -2. 1/2 times 6 is 3. 1/2 times -2 is -1. Doing our Y values now, half of 2 is 1, half of 0 is 0, and half of -4 is -2. So those would be the ordered pair if the transformation was just a dilation. But then it says it needs to rotate 180 degrees. So our coordinate notation tells us to take negative of the X and negative of the Y, or the opposite of X and the opposite of Y. So finding our X values first. Opposite of a -2 is +2. Opposite of 3 is -3. Opposite of -1 is +1. We'll do the same with our Y values. We'll have -1, 0, and +2, taking the opposite of each of those values. So those are the points that we will graph in order to show the sequence of transformations. So our first point will be X prime, the next one will be Y prime, and then finally Z prime. We started with X, Y, and Z. In our image, they will be called X prime, Y prime, and Z prime. So let's graph those points. We have 2, -1, and label it as we called it X prime. -3, 0, again labeling it Y prime. And 1, 2, that one is Z prime. Connect those points to show your triangle. And so the final part of this question asks us to determine if the resulting image is a congruent figure or a similar figure. So notice how it did rotate within the coordinate plane. Our Y point rotated around to here, Z point rotated around, and each time that is a rotation of 180 degrees. But also notice how it changed size. It got much smaller, and that was because of our dilation. Because it changed size and not shape, then it would be a similar figure. So the sequence of transformation produced a similar figure. We could have looked at our original problem given, and because it said dilation, we know that that would produce a similar figure. In the other transformation, we cause the image to be a congruent figure. Let's look at example 2. Here we're going to have a triangle that's going to translate up 5 units and then reflect over the y-axis. So again, start with your coordinate notation. Translating up 5 units, your x value will not be changed. Your y value is what will change by adding 5 to make it go up 5. And then our reflection across the y equals x line, go back to your chart for reflections. If it's a reflection across y equals x, here's our coordinate notation. It says that we're going to swap our x with our y. So the first part is understanding the coordinate notation and making sure you set that up correctly in order to get your ordered pairs. So our points for x, y, and z, again, x is at -4, 2, y is at 6, 0, and z is at -2, -4. Using that original graph, we see those points. So let's first find the ordered pairs for when it translates up 5. The x value will stay the same, and the y value you'll add 5. So 2 plus 5 is 7, 0 plus 5 is 5, -4 plus 5 is +1. And then to reflect it over the line y equals x, we will now just switch places our x and y values. So our first point, or our first number in the ordered pair, will now become the 7, the 5, and the 1. The second number of the ordered pair will be our x value that was in the previous step. It now becomes our y value. So -4, 6, and -2. Just switch in places with those x and y ordered pairs. So these will be our new x prime, y prime, and z prime points. Let's graph those to see our sequence of transformations. So we have 7, -4, and that is x prime. Be sure to label your points. We have 5, 6, and that one is y prime, and then 1, -2. That one is z prime. Connect those points to form your triangle. So there we see our new triangle, x prime, y prime, and z prime for the image after the sequence of transformations. We see that even though it has moved within the grid of the graph, it is still the same size and same shape, so that means that it is a congruent transformation. So the sequence of transformation resulted in a congruent figure. We could see from the original problem that because we did not have a dilation that causes it to grow by getting larger or shrink by getting smaller, that it would have resulted in a congruent figure. Only dilations will result in similar figures. Let's look at one more transformation. Number 3, we have the triangle JKL that's going to reflect over the x-axis and dilate by a scale factor of 2. So again, starting with your coordinate notation, reflecting over the x-axis, go back to your chart to see the coordinate notation for reflections. So reflecting over the x-axis, you're going to keep your x value the same, but your y value is going to become opposite. Now to do a dilation by a scale factor of 2, you'll take your x value and multiply by 2 and your y value and multiply by 2. So let's list those ordered pairs for J, K, and L. J is at 2, 4. K is at 1, 1. And L is at 4, 0. Finding the ordered pairs first for the reflection, it says keep your x values the same. So we'll still have the 2, 1, and 4. The y value becomes opposite. So here it'll become -4, -1, and just 0, because 0 is neither positive or negative. So it just stays as 0. Now to do the dilation, we'll multiply each value by 2. So 2 times 2 is 4. 1 times 2 is 2, and 4 times 2 is 8. For our y coordinates, we get -8, -2, and 0. So those points when we graph them will be J prime, K prime, and L prime. So we have 4, -8, as J prime. We have 2, -2, as K prime, and 8, 0 as L prime. Connect those points to form your triangle. And we can see with that triangle, it has reflected over the x-axis, reflecting over. And then it also dilated and grew large with that scale factor of 2. So because of that, it produced a similar figure. Again, that was because of the dilation that we're going to have similar figures and not congruent figures. All other rigid transformations result in congruent figures. So let's look at some without graphing the sequence of transformations. We're going to determine if the resulting image is a congruent figure or a similar figure. So first it says we have a translation. It may go up, down, left, or right. Then it says it's going to reflect over a horizontal line and then have a rotation about a point, and they call it Q. So each of those transformations are rigid transformations, so that means it's going to result in a congruent figure. Example 5. It starts with the dilation of a scale factor k equals 4, and because that's greater than 1, it's going to grow larger. So it's going to be an enlargement. Then it's going to rotate around a point, and it says point P, and then have a reflection over the x-axis. So going back with this dilation, because of that dilation, it's going to cause it to grow larger and produce a similar figure.